Hello everyone, today I'll be digging on the authorization code flow in OAuth 2, and I will include of course the details when you need OpenID Connect, meaning that you don't want only to authorize an application or a client application to access something that belongs to you, but you will also want to authenticate the user, meaning that you want to later check the roles of the user, the email of the user, profile information, and so on. Because most of the times when this protocol is used, it's to authorization, meaning that you want the system to connect on your behalf to something. So you want to give authorization, and for that you need a token. But in some systems, you want also to be connected as a user. And it's important for you to get the profile user, the email, and some personal information. It's not only about the application access some of the systems, but you also want to make sure that the user is authenticated. So this is the big difference between authentication and authorization. In this video, I will show you all the steps necessary, all the HTTP calls that are used so you can understand deeply how this protocol works. So when you will be developing something using this protocol, you will understand why some questions or some required information is asked from you, because some of the information should be provided by you to a system that's to make sure that it's all these authentications and authorizations work. So let's start with a small introduction. If it's the first video that you are seeing on this series, I already created previous videos about all the flows and what is OAuth 2, OpenID, things like that. But now I'm going more deep on this subject. So let's start with the introduction, a fast one. So what is authentication? It's proving who you are, meaning that you have to prove that you are you. At the end of the day, it's as simple as that. Authorization is after you are authenticated, what can you do? It means that authorization always as a requirement for someone to provide some authentication first. So first, who is this person? Then what can this person do? When I say person, can be, for instance, an application or a service. And the big question is, how can a third party app get permission to use your data from another service without ever seeing your private login details? Because if you see my previous videos, one of the issues, I wouldn't say a long time ago, because computer science, it's moving really fast. But I remember to provide usernames and passwords and store in specific place so a service can connect you to other service. Today you can use tokens because we have this great protocol called OAuth 2. So the need secure delegation. That's what this OAuth 2 resolves. It's imagine that you have a new photo editor waiting to organize your photos on Google Photos. So you have an application that using artificial intelligence can organize your photos. Of course, it's an application. It's not you that will organize these photos. It's another application. So you want to give permission for this application. Imagine it's a cloud one. It's a service that you buy. You pay every month something. But of course, you don't want to provide your password. You want to provide limited access to this application that will work on your behalf, but very constrained to something that you want to provide. You say, okay, you can read my photos and you can create some files to organize them, but you cannot change the photos. You cannot remove the photos. You cannot share the photos. You can only read something about the photos because that's enough for you to organize them. So you are delegating to an application, so you don't want to provide your authentication details. You need to authenticate at least once, but then you just want to give a token that can be used, and this token has enough information to say, okay, you can only do this. So you don't want to give your Google password directly to the photo app. And delegation means granting limited permission to an app to access specific parts of your data on your behalf. That's the main idea of this protocol. So we need a way to do this that keeps your password safe and allows you to take back permissions whenever you want. That's where OAuth 2 enters in the scene. So it's the authorization side. It's not authentication. For authentication, you need OpenID, and I will talk about it. I will show you the flow using OpenID later after I provide the first flow for the authorization. So OAuth 2 is an open standard that helps you solve this problem. What is the problem? To give some delegated authority but constrained to the permissions that you want to give to a specific application. I usually say this example. It's when you go to the airport, you enter on the airport, you buy a ticket plane, but you can only enter on that plane. You are in the whole airport. There are a lot of planes with a lot of trips to everywhere, but your ticket only gives you permission to a specific place in the plane, probably to a specific meal, and to that specific plane. That's it. That's your token. So you authenticate when you arrive to the airport, but then you receive a ticket, which is your token to access a specific thing inside the airport. So there are several grant types in OAuth 2, and which we call flows. And today I'll be talking about the authorization code flow, and can advance to you that I will talk about at least three subjects here. One, it's the common or most popular authorization code flow for authorization. Then I will introduce the OpenID, meaning that you want authentication. It's quite similar, but you receive as a bonus another token. So you will receive 3 tokens at the end. It's strange, but that's how it works, and there is an explanation for that. And then I will introduce PKCE, which is, imagine that you want to use this protocol, but you are in a browser, so you don't store sensible information locally. For instance, the client secret that I will explain in a moment what it is. So why is this secure, the authorization code flow? Because it uses a temporary authorization code, and I'll explain in a moment what is this. It's very short-lived and it's exchanged for actual tokens, meaning I can do a kind of a spoiler alert. You want to start this authorization, so you will create a kind of it's not a password, but it's a code that will be generated, and you provide a state, several information, and then this will make sure that there are no middlemen, and the entity that initiated this flow is still the same until the end. That's the main idea. But at some point, of course, you have to provide a kind of a password, your username and password the first time, and later, probably if you are in a backend, you want to provide something which is the client secret. But let's see the flows, the actors in this flow. So you have the resource owner, which is the person. It's the owner that's of the resource. The person who owns the protected data. In our case, it could be the photos, emails, Google Drives, OneDrive. There are a lot of systems that they use this protocol. Then you have the client application. It is to this client application that you want to delegate some authority to do something on your behalf. Okay, so the app that wants to access your data. In our case, would it be the application that wants to organize your photos, a cloud service that you pay to organize your photos in a very nice way. So, and on the client side, you can usually have 2 different types of clients, and that will change the way the flow works. One is a confidential client, like on the backend, as a secure backend where you can store a secret. Since it is a backend, you can store it. Of course, you have to protect this backend, but you can store a secret. In our case, will be the client secret, and I'll explain in a moment what it is. But in most modern applications, apart from the backend, there is a single page application most of the times, or a mobile application, and you don't want to store secrets in these applications because it's in the hands of everyone. So someone with a little knowledge can try to break your secret, and in this case, you cannot store a client secret, like for instance the password of your client application. And there is a different flow here, which is the PKCE, that will help you to overcome the difficulty to store a local secret. Then, of course, you have the authorization server, which is the guy that will authenticate you, that will generate the tokens. And then you have the resource server, usually an API, for instance, that the service that your client application wants to access to do stuff. For instance, to consult your photos or metadata about your photos so they can be organized. So there is the person, there is the application to whom you want to give the permissions. There is the trustable authority that will provide the tokens, the one that you trust to provide your username and password and generate tokens. And then there is a resource server where this application wants to access. So at the end of the day, everything that exists here is solely to give something that the resource server accepts and can provide the data that it owns, like for instance, your photos. So the basic flow, it's like this one. So we have the resource owner. The user wants to use a specific app. Imagine that it's in the browser, or it can be a mobile application. It requests authorization to the authorization server. Say, okay, I want to connect to these research servers. I need to access this API to get some information about the photos. And the authorization service say, who are you? Or you are already logged in. Maybe you have a cookie or something local, or you are not. And it will provide you username and password. Who are you? And please authenticate. So the first thing that you have to do is to prove yourself as the user, as the owner of the resource server where you want to access. Now it authenticates, it accepts, okay, I understand who you are. So now you ask to grant permission to this client app, meaning I want some permissions for this client app. And of course, all the client apps, they are identified by an ID and a secret that should be pre-registered on the authorization server. The authorization server knows which client applications can access to it. It's not that you can take any client app and just use Google SSO to do this kind of stuff. No, you have to create an app or a client app on the SSO or these authorization servers, and then because you will later have to send the identification of this client. So you ask for permissions in the name of this client app to the authorization server, and you ask it and the authorization server. Okay, so let's start our negotiation. So it sends you a code, meaning, okay, keep that code and send me this code later so I can trust who you are. Usually when you do this first request, it can be configured or not, but most of the times there is some configuration, kind of a whitelist URLs, if you have a backend, where this authorization server will send this code. You can, this request, send the address of the reply, or it's already pre-configured on the authorization server. And then it will answer to that, let's say, callback address with this code. And if it's really well configured, it says, okay, you will accept this code. And now you forward the code to the client app. In this case, can be our backend if we are using a backend. If it's not the backend, if it's just a single page application, I will show you later how you can do it. So this client app, since it is it's a backend application, you already have their kind of the client secret stored, which is, let's say, you have your username and password as a user, but the client app also contains a username and password, which is called client ID and client secret, that was generated here in this authorization server. So now you forward the code to this client app here, this backend, and you send the code and the client ID and the secret to the authorization server. So you are, let's say, a kind of authentication the client app on the authorization server with the code that you received. So you say, okay, I am the guy that initiated everything. I received your code, and now I'm sending the code. So I am that person, and I want you to authenticate also this client app, because I'm requiring something for this client app. And the authorization server, okay, it's you. I have you provide me the client ID and client secret correctly, so I'll return the access token, refresh token, and ID token, for instance, if you're using OpenID. So you can receive ultimately, I hope I'm saying correctly, 3 tokens: the access, refresh token, and ID token. But I will show you details in a moment. And now you use one of these tokens, usually the access token, to connect to the research server, meaning the client app will access, so I can consult your photos, receive the information about your photos, and they can show the organized photos in the browser for the client user. And the only time that it was necessary for you to access was the first time for the username and password. And of course, if you are navigating a site, now you are clicking on things there. So this is the flow, the authorization code flow. But let's see in real what happens behind all these scenes. So let's say the step 1 and step 2 initiates authorization. So users access application, you open the photo editing app. Now the photo app, your browser sends you the authorization server, authorization endpoint. So you have this client ID, redirect ID, scope, and state. So this will be the first request that your application. Usually most of these things are hidden behind some plugins that you usually do, but you can do it manually and it should work. Okay, so you call the authorize. Imagine that it's on your server. This authorize. Sometimes you have a bigger, like say accountsgoogle.com/authorize, and then first you say response type code, which means it defines your flow. It's the authorization flow. It's the principal one. Let's say I will discuss 6 in 6 different videos. Today I'm just discussing this one, which is the code. So, and you send your client ID. So you're saying I want to provide permissions to this application that is already registered here on the Google. And you should send to me the code that will generate, that we saw here, this code here, okay, to this address here, this callback, and this is the scope. So I authorize this client ID just to read only the photos. I will have a specific video to discuss the scopes, what are they, what are the strategies to use them, and so on. But for now, think of them as a kind, what are the permissions for the client? Usually users, they have permissions to do stuff in an application, but here you are saying which permissions or authorizations a client, this specific client, has when accessing your data. And in this case, my data, it's photos, that it can only read only the photos. Okay, and of course it will be here on the resource owner server, the resource server responsibility to check, of course, later the scope and allow or not specific calls to APIs. And then there is state, which is a random string for security to prevent tampering. And this will be exchanged between the server. Okay, so that's the first request. Now there is authentication of the user to say, okay, I am Jose, this is my password, so I'll do the authentication, and it will ask me, okay, but do you allow this client ID to access this your photos as a read-only? And you say, yes, I grant that permission. So I allow. Probably you already saw this in some websites when you navigate. Now you'll receive, there will be a call from the server, the authorization code, the authorization servers to you on the address that you given before. That can be pre-configured or you provided here, this callback. So it will send you the code here. It will generate the code, the server, and it provided you the state, that one that you created before. So you create this and the response say, okay, validate please that you are you. This is the state, and I'm providing you this code that you should send me back so I can give you the token. And now you do a post, which is the latest step, to the, let's say it's Google in this case, and you say, okay, I want an authorization code. This is the code that you sent me. Okay, after everything, it's okay, please call this address, and I'm providing you the client ID and client secret. And you only see this client secret when it's a backend that it's calling, that is doing this call. If it's a browser, you won't see this client secret. And at the final of this video, I'll provide you the flow with the PKCE, where we doesn't use the client secret because you are in the browser and you don't want to store the secret or a password in the browser. So these are a different technique. But usually when it's the server side doing this last step, it will be a client secret that will be sent. And of course, everything went well. You will receive a JSON with an access token. The token type, it's bearer, the expiration time, a refresh token, so you don't have to constantly, because there is, after this time, it will expire, but you can use this token to renew and receive another token for you to use. And the scope associated, and if it's an OpenID, you will receive another entry here called ID token with something similar like this one, but I will explain in a moment what it is. So now with all these permissions, every time you need to access the API, the backend, meaning the resource server, you have to provide this header, which is the authorization bearer and this. And how do you know that it's bearer and it is this one? Because it says here token type bearer, and here the token, it is this one. And you provide it here, and the backend will validate this again with the scope to make sure that when you call an API, the API will allow this kind of scope or constraint. And after that, you are okay to use it on your application. Now, this is the authorization flow, the regular one. This is how it works. It's, at the end of the day, just 3 steps. Now imagine that you say, okay, but I want to authenticate the user. I have a website, I want to authenticate the user, I want to use some APIs, but I need also information about the user. I want roles, I want email, I want this photo. It's not about solely giving permissions to the client, but I want also to make sure that user authenticated, and I need personal information, and I want to validate that this user is authenticated or not the client. The first flow that we saw, it's to authenticate the client, the application that needs to connect to an API. Remember that the main flow, it's about delegating authority to an application. But there are times that I want to delegate this authentication or this authority to an application, but I also want to authenticate the user and validate things about the user. So we want both. And in those cases, you want to use OpenID. OpenID, it's not a different one. It's a protocol that behind the scenes, it's the OAuth 2, but it's a layer above. So it uses everything about OAuth 2, but provides additionally authentication for the user. So as it states here, so it builds on top of OAuth 2. It uses the same flows, but add an extra information, which is the ID token. Well, this ID token, what is generated, when I mean that it does everything that we saw here, if you return here, at the end, everything here is similar, but at the end, you will see here an ID token, an additional one. Okay. So, and this token, if you decode it, you can go online. It's a JSON web token. You can go, there are these attributes that you see, that we will see on the JSON. So it's a unique identifier for this, the sub, meaning the owner, let's say, of the authentication, who issued the token, the authorization server, and you can check and you should validate these values on your client to make sure that no one in the middle gave you a token to another server, so that can steal information for you. Now the audience it's where you, for instance, provide the name of the backends that the user can access, or even your client can access. You see this property most of the times in the access tokens also, to make sure that, okay, you have this scope and you can access this backend, because you can issue a token to multiple backends to access multiple backends. Okay, then again, the expiration, the time of expiration for this digital ID card. So this is the token for the user, not the client token, the access token. Okay, and when the token is issued, and now you will see information like name, email, picture, and other kinds of things. These tokens, for instance, if you use applications like Teams, application that where the user do some calls and things like that, where the user is really important to make sure that the user is the user. This application usually they need to access backend APIs, so they will have access tokens, refresh tokens, but will also have ID tokens, because you want to make sure that the user it's on the call, it's that user that authenticated. So that's scenarios where we'll see most of the times these three type of tokens. So it's this is very similar to the one that we saw previously, the OpenID Connect flow. It's quite similar. It's simplified here because they are the same steps, but at the end, there will be the return of ID token by the authorization server, and you should validate the token, the signature, the claims. The claims, it's the things that you know about the user, like the email and other information, which roles it belongs, and things like that. So you usually these tokens, it's signed, and you want to make sure that it's a valid one, and you want validity. It's not mandatory for you to do, but you should do it. Okay, and then you establish a user session based on this ID token. Probably you just store this ID token in a cookie or in the browser storage, and you send it to the backend when it's necessary from the browser. That's one way to do it. But at the end of the day, just in summary, it's really similar to the one that we saw before, but you will receive an additional token, which is called ID token. Okay, that we'll use for user stuff. When you want to need to access something, but it's the application that needs permissions, use the access token. If you want to get information about the user, you use the ID token. It's the most abbreviated way for me to say about the difference between these two tokens. So the key difference for OIDC, so in step 2, the scope includes OpenID. When you request scopes in OpenID, you have to provide this. OpenID is required. Okay, that is related with authentication, and usually you also add profile, because usually you need email, usernames, and things like that. And in step 8, if you go to my previous slides, it always returns the ID token. And of course, in step 9, don't forget to validate the ID token. So at the end of the day, it's when you redirect, you have to provide this scope here, OpenID and profile, additional to the ones that we were asking about, to photos.read-only. That's so we are requiring 3 scopes if it's for our photos application, and then it will everything will happen as we saw, but you'll receive also the ID token, and you should validate what we'll be validating, these kind of things here. We want to make sure that it's the ones that we expect. And why should we expect that? Because we are the developers of the application, and we should know what they mean. Okay. If you want to see just a high level way to do it in Python, it's not important for you, but if you want to develop something with Python, it's a very simple language for this. But you can also use things like, I know that Spring Boot contains a really good client, which I think it's even called OAuth 2 client, if my mind is not tricking me, or OpenID client, where it by default it already provides you a lot of these configurations. So you just have to create one or two beans, and you can implement something very simple. And you can even use, for instance, GitHub as your authorization server, and it should work. So, but at the end of the day, if you want to implement something, you can see here JSON Web Token. It's one of the, it's important because most of the tokens are JSON here. So I have the client ID, client secret. Of course, this is for the backend, not for the browser. The redirect URI, where you want to receive. Imagine that you create here a simple web server, and you provide here an address where you want to receive the callback from the server. And here will be the code that you'll receive from the Auth server. It's not the token, it's the code that will be sent later to receive the token. The token endpoint, where you should ask for the tokens after you receive this code. And then here, if you are using OpenID, you can validate the ID token just calling the authorization server and pass your ID token to this address. Usually this is quite standard, and you can send it and it will validate saying if it's okay or not. That's one way to validate. So this is just a way to put in Python. So the grant type, when you want to get access to tokens, you provide the authorization code, the address to receive, client ID, client secret. It's as simple as this. And then you do the request, you receive here the JSON, and you just get the access token, refresh token, and ID token. This is an OpenID way to get it from the JSON. It should be as simple as this. Of course, there is some missing code here, but I think if you understand or you understood everything that I said and you know Python, it should be easy for you to just complement this code, what is missing here, and provide here a very simple web server, HTTP server in Python, and you should be able to implement it and test it. But of course, if you go to the OpenID website, they have a really good simulator where you can see this information. And if you are comfortable with Java and Spring Boot, out of the box, it already contains a great library for OAuth 2, where most of these things, they are already implemented. And if you know or not, Spring Boot creates in a very simple way, just a few lines of code, a web server. So it should be simple to implement all of this. And then there's an explanation if you want to read here, if you want to verify, just some examples about how to verify what's in the token. Here you can see how to extract things and what should you validate, the audience, the SES, and things like that. If you want just to pause and you want to check here, but you can also research on the internet more details about this. So challenge and important considerations. Of course, always use the state parameter, the one that we saw at first. It is used here on the CSRF to protect the middlemen and things like that. So the cross-site request forgery attacks. The authorization server must strictly enforce a prerequisite list of allowed redirect URIs. As I said previously, sometimes most of these redirect URIs that you put on address, they are already on the server, authorization server. If you know where our backend exists that can receive the token, we can provide directly there the address. Unless you are in a browser and we don't have a backend, the server side, and the server side, it's the target of our client. It's not our client. In those cases, of course, you cannot pre-register, let's say, on the authorization server, but for that you should use a different adapted flow called PKCE that I will talk about it in a moment. And of course, the secure token storage. If you are on the backend, it's okay. Otherwise, if it's in the browser, you should be careful what you want to put there. You don't want to put their client secrets, for instance. So access tokens, keep them out of client-side code if possible. For web apps, storing HTTP-only cookies for secure side session. They are short-lived. Refresh tokens, they are long-lived and very powerful. Store them with extreme care on the server side, always encrypted and rotated after use. Sometimes you can, sometimes you can't, but you can, for instance, put them on the storage of the browser. You can try to encrypt them or something, but they are not as secure as you think. But even if at the end of the day, someone stole something from the browser, it means that your browser can be accessed by multiple people. And it's not a good idea to do authentications, as you know, in public places. So this is something that works if you are not in a public place. And if you are, please log out and make sure that the application is implemented in a way that cleans all this information so the next user will not get advantage of the existence of these tokens on your cookies or storage. So be careful with that. Public clients and PKCE. So if your public clients like single page applications like Angular, React, and things like that, they cannot securely store the client secret, which means when you are requesting for the access token, you cannot send the client secret because you don't want to store it in the browser. You don't want it to put in the code, otherwise the purpose of this protocol will be completely null, let's say like this. So you need a different way to do all this flow without the client secret to request an access token. And for that, you should use something that is called PKCE. And PKCE, rather than use the client secret, it starts to generate two things. One, it's the code verifier and the code challenge, but we'll see in detail what is this. So what is PKCE? It's a proof key for code exchange, and it prevents authorization code interception attacks. Okay, it doesn't encrypt nothing, it doesn't protect nothing local, but it prevents authorization code interception attacks. Remember that you don't have now the client secret, so you cannot prove who you are. So the only thing you can do is to make sure that you start the communication and the authorization server understands that when it ends all this negotiation, it's still you on the other side. But you cannot provide a client secret. You can prove who you are as a person, but you cannot prove the client, the single page application, because it can be executed in any place. It's not like a backend. The backend, you understand, it's a controlled application that sits probably hidden in a cloud or something. So you can put sensible information there. But in a browser, it can be in any place in the world. So you cannot store sensible information. So the only thing that you can make sure is try to avoid any interception on your communication. So if you started and you did username and password, and if it's possible to prove at the end that you are still the same person, it should be okay. So no need for client secret in public clients. Ensures the same client that initiated the outflow is completing it. That's the main objective of the PKCE. So what are the steps? The client generates a code verifier, the code challenge. It works very similar in a way to HTTPS behind the scenes. I know I'm stretching too much, but it makes there is some similarity here. So it sends the code challenge in authorization request when it first starts, gets a code like the code that we saw that it's received that will be used to get the access tokens, and then it sends the code verifier a token request that it generated at start, and it was generated when you authenticated. So you should be the same person. It's like it's representing you in an authenticated way. And since you are always sending this code verifier there at the start, you will see that the server will keep on the authorization server will keep on his side this code verifier, and then later we'll verify it again if it's still you that it's sent. So if you use this code verifier with this code, the code means that it was generated by the authorization server, and the code verifier means that it was you that started things. So you can cross these things and make sure that they are really tied up between them, so there were no interception in this process. And then the server validates if it matched the code challenge. So let's see. So it's very similar, the client ID, the redirect, the scope, the state, but now we have these two additional ones. One is the code challenge that you can generate here, and you have the method for the code challenge here, and you can say that it's hash 2256 here, and it's just a hash method. Okay, the other ones are the same, but you have to provide at first these two ones, the code challenge and the code challenge method. Now there will be a redirect after login, so the server will reply to you. It say, okay, this is the code that I generated, and this is the state. It is not replying with this information because the authorization server will keep this information on its side. Okay, now it's very similar to the other one, and now when you ask for the access token, you provide the code that was supplied to you here, like our first flow, and the redirect, meaning, okay, everything went great, please forward the request, the tokens that will generate to this address, and this is the client ID, but you don't see now the client secret, you just see the code verifier again. This is the code verified that you are sending, that you send. And you should receive the code. So on the server side, the authorization server will do the hash of this, and it will make sure that it's the same where when everything started. So what the server does, rehashes the received code verifier, this one, and after the hash, it compares with the code challenge, which is this one. Because and you will hash using this algorithm, this method here, and issues the token if they match, meaning it proves that it was you that start everything because you did the login and you provide this challenge. And when it actually say, okay, the code that you are sending now is still the one that I received first, meaning that if something in the middle try to intercept and generate a different one to replace you by the hacker, it will fail, because when it hashes the code, it will say, no, it's not the first one that I received. So it will not issue the tokens. So this is a way if you want to use in JavaScript, just an example. It's not complicated, but if you want to try using JavaScript, this is one way to generate the code verifier and the code challenge. So why authorization code flow is preferred? First, in asset security, the most significant advantage. By exchanging the code for tokens in a direct back-to-backend communication, the sensitive access token is kept away from potential vulnerable client-side event. This is when you have a server side to receive the tokens. If that's not the case, of course, you should go to PKCE, the flow that we saw right now. So client confidentiality. So for web server applications, use of the client secret adds another layer of authentication because it authenticates the client. But again, only if we have a web server and the backend. If the client app, it's not a backend, it's just a portal or Angular application, single page application, you don't have the client secret and you don't want to use the client secret there. The refresh token support enables seamless user experience by allowing applicants to obtain new access tokens without requiring the user to authenticate, meaning that usually you generate a token say for 30 minutes. After 30 minutes, you can use the refresh token to generate another one and have another 30 minutes. And you can do it in this way. There is some advantage of this. Some people say, why putting so small scopes of time? Because if you detect some anomaly on the access over account, and most of the servers will send you an email saying someone is accessing your account in another place, that it's not your common IP or common geolocation, and you can say, okay, it's not me. So they will block, they will invalidate the refresh token and the issue token. So there's no possibility to, so maybe someone has access, it will only have access for half an hour, for instance. After that, will just breaks because you cannot reissue, they cannot renew the token using the refresh token. Okay, the Auth flow, it's an industry standard, which is quite great because there are a lot of people will want to break this, and if there is a weakness, it will be public, so it can be fixed and you can check if it's a good protocol or not. That's one of the advantages to use very public algorithms about encryption, things like that. Security should be as public as possible because it can be analyzed by everyone. Some people say, okay, if I hide the details of this algorithm, it will be more safe. No, it's not. It will not neither be safe nor secure because probably it will be weak. And if there is a weakness, no one and knows about it, and no one can say to you that there is something wrong there, and the hackers will discover it and they will take advantage and you don't know. That's it's a kind of a paradox, but that's how it works. The most secure way of doing things is using public things. Conclusion. So the authorization code flow, especially with OpenID Connect, provides a robust and secure way to manage authentication and authorization. That's the main purpose of this. It allows other applications, not only you, to access your data, meaning access your data on your behalf without ever seeing your password. That's the main purpose of this protocol. And of course, you have to try as best as you can if you are belong to IT, software engineering, architect, developer, to understand all these flows very deeply, because sooner or later you have to integrate them, and you want to understand how they work. Even if you are implementing, it's I think it's a big advantage if you understand all the details. At least when some strange errors starts to appear, you understand why they what are their meaning, and that's the first step for a good troubleshooting of any other application. So thank you for watching this video. I hope it was useful for you. It was quite detailed, quite deep about how it works. I hope now you understand better this protocol. Be free to ask questions about this, put on my channel, on the comments. Please subscribe, share with your friends, and it will give me motivation to record other videos. So thank you for watching, and I hope to see you in my next 5 videos, at least about this series. I'm providing other videos, of course, on my channel, but for this I will provide 6 flows. I know that usually people say that there are 4. There are 2 that are somehow outdated, but I want to talk about them in my future videos so you understand. Maybe you are using an application that is using them, so you have to understand also. So again, thank you for watching, and I hope to see you in my next video.